we've got our monthly loan formula that we can do for our calculations, but on the internet they have loan calculators. There's tons of them. Now, I cannot attest to the accuracy of all of them, but usually if you go do 2 or 3 of them and you get the same answer, then it's probably accurate, you know. But they'll give you a lot of info regarding your loan balances, payment amounts, total interest to be paid, etc., over the lifetime of the loan. So what you'll do is you go online and you'll enter, say you're going to take out a $10,000 loan with an APR of 7.5% for 5 years. And then you enter that and then you get info. So here's our loan calculator. We're going to take out, what do you want to take out? How much do you want to take out? $50,000. What do you do? 5 years? Let's do 6 years. If we're doing 4.5% interest per year, if we calculate this, what? No, it should just calculate it. There we go. Your monthly payment would be $793.70. You'd make 72 payments. Okay. Now, you'd pay it off if you took it out today, you'd pay it off on September 25th, 2020. You could add money to our monthly payment. We could make that, instead of being $793.70, let's just make it $800, right? Because what's the difference of $6.70? What'll happen then is we'll reduce the loan length. We added $6 a month, right? We reduced the loan length by 3 years. Oh, wait, I didn't mean to add 800. That was the problem.
Can we see that again?
Hold on, okay. Let's just... That's the other thing. If you don't enter the information right, the calculator's no good. Okay, guys, shh. We're taking out a $50,000 loan. Our payments are $793.70. We're frozen. Okay. This is the amortization table. Remember how I told you the principal gets lower or higher as you go, and then the interest gets lower? As you can see, that's happening here to the end where our interest is only $2.97 on the last payment. So we'll make 72 payments.
What happens if you do add in the extra payments?
That's supposed to be $6.30. Okay, we're going to be from September 2020. It's frozen. It's thinking. No, it didn't change it. Okay, but it did calculate. And your last payment ends up only being $200 instead of $800. So that's what happens, is it took it off the last payment. But if you looked at this, I believe that the interest would have gone way down. If we actually compared the interest every month, it would be lower. So, but that's just the kind of thing that they have online that you can find. Again, though, I cannot guarantee the accuracy of every single loan calculator online. I didn't write the code. I don't know for sure what formulas they're using. But if you go to a couple of them and they all give you the same information, you can pretty much guess it's going to be about right. Yeah.
It says payment amounts, comma, then it's at ETC.
Etc. Yeah. So like, see how on there we got like the amortization table, so we could see what our payments were doing every month. We could do that putting in extra money thing. There's other stuff that you can do. Ah, gotcha. It's ETC. Okay, so we're going to determine the total interest owed on a 5-year, $10,000 loan at 6%. We did this on Tuesday, but remember we put the principal in is how much we're borrowing. 6% we have to convert to a decimal. Don't forget to convert to decimals. 5 years. Okay, first things first. I'm going to do 0.06 divided by 12. Okay, and that is going to give me 10,000 times 0.005 times 1.005. And then the second thing I'm going to do is 12 times 5, which is 60. And then the third thing I'm going to do is 1.005 to the 60th. Okay, and then I'm going to multiply that by 0.005 and then times 10,000. Oops, I forgot the minus 1. And that's your monthly payment. But I'm going to make 60 of those. So I'm actually going to pay $11,599.80. And then I'm going to take that and I'm going to subtract the original 10,000 I borrowed. And that's my interest. Okay, let's give you a hypothetical situation. You know you want to borrow a car and you want to borrow $25,000 because you want a Hyundai. All right. So you know you want this car. I want this is the car. I have to get this car. And then you look at your budget and you go, I can afford $300. Well, before you go talking to them, you can figure out how long your loan has to be. If you take the amount of money you want to borrow and you know the interest rate and you know how much you can pay every month, you can figure out what the length of the loan should be. And that's what this formula does. Now, we haven't dealt with this particular concept before, so we want to go over this natural log right here, ln, is the natural logarithm. Okay, you know when we were doing compound, Just natural log. Just this one. Okay, remember when we did continuous compounding and we had E? And E was about 2.718, and I told you E was the base of the natural logarithms, but I didn't really get into what that meant. Okay. You know how you have multiplication and division? And multiplication and division undo each other. And you have square roots and squares, and they undo each other. They're opposite operations. Logs and exponential functions. That's where you have variables as an exponent, not as a base, but as the exponent themselves. Logs and exponentials undo each other. E is the base of the natural log. So when we talk about the base, that's the number on the bottom. So if you have e to the x, e is the base. If I take the natural log of e to the x, I'll get x. They undo each other. E and natural log undo each other. Okay? That's all you really kind of need to know for that. For this part, what you need to know is it's a button on your calculator. Okay? I will pull it up on. This is just a button on the calculator. ln. T is the length of time. M is the borrowed money, monthly payment, actually. Monthly payment. No, hold on. M is the monthly payment. P is the principal, so this is the total borrowed. And R is the rate. So what we're going to do is we're going to do the natural log of 300 divided by 25,000 minus the natural log of 300 over 25,000 minus 0.059 over 12. And this is 12 times the natural log. Okay? You have to do all these divisions first. Okay? So 300 divided by 25,000. And then 0.059 divided by 12. And that's going to give me
Is that 8? Is that 0 and 12? Yeah, I said that.
which one, sweetie?
The .012, but I saw it
Oh,
over
okay.
there. Yeah.
Oh, I thought that was a 6.
Yeah.
I thought it was 8, but
Monthly. Yeah, the monthly payment he wants to make. Yeah. All right, so then after you've done the divisions, I need to do this subtraction next. So I got 0.012 minus 0.004917. Third, we take the natural log of each. So I'll do that here. 0.012, natural log, so I've got negative 4.4228. Minus .007083 natural log is negative 4.95 divided by 12 times 0.0049. Okay. Then I do this addition because two negatives make a positive. So I have negative 4.4228 plus 4.95. And then I have this multiplication, 0.0049 times 12.
That's negative 4.4.
Yeah, this is a negative. Oh, what did I just do? Yeah, this is a negative, and then you have two negatives, which makes that a positive.
Okay.
So it'd be negative 0.722.
No, it's positive. Because I did minus plus. That became a plus. And so you get 12.3 years.
To pay for
We have to run downstairs.